Hi everyone, welcome back to the channel. In this video, we shall try to learn about the concept of coordination chemistry. It's a very important concept in the field of inorganic chemistry, and the most important research is going on in nowadays regarding the coordination compounds and their characterization. If you come to the main basics of the coordination chemistry, here if you consider a simple ionic compound, say for example common salt, that is NaCl, so which is mainly composed of two ions, that is cation Na plus and the anion Cl minus. So by the combination of the cation and anion, we are getting the simple salt, what we call as NaCl. So we are having one more ionic compound, that is NH4NO3, that is ammonium nitrate, which is framed by the combination of NH4 plus and NO3 minus, that is nitrate. So collectively you will be getting ammonium nitrate. So these things, the NaCl and NH4NO3, they are simply called as salts. Strictly speaking, simple salts. The word salt is actually given for a material when it is formed as a neutral product by the combination of acid and base. When acid is neutralized by a base, we are going to get a neutral compound, and that neutral compound is simply called as salt. And the salt will be consisting of one anion and one cation. Since the constituent particles are ionic species, we used to call the material as ionic compound. And here you can observe in the above two examples what we have given, that is NaCl and NH4NO3, sodium chloride and ammonium nitrate. These two salts, the salts of this kind are actually called as simple salts or simple inorganic salts. Simple salts or simple inorganic salts. The reason for calling these materials as the simple salts or simple inorganic salts is they are consisting of only one cation and one anion, or only one type of cation and one type of anion. That's why we will be calling them as simple salts. And in simple language, we used to call the cation as basic radical and anion as acid radical. So a simple salt is one which is mainly composed of one acid radical, that is anion, and one basic radical, that is cation. So simple salts are the inorganic salts which are composed of one acid radical and one basic radical. And here we have the simplest exemplifications for simple inorganic salts, that is sodium chloride. Here the basic radical, that is cation, is Na plus and acid radical is Cl minus. And here in case of ammonium nitrate, the acid radical is NO3 minus and basic radical is NH4 plus. Similarly, we can give few more examples for the simple salts, that is Al2SO4 thrice, that is aluminium sulfate, which consisting of basic radical Al3 plus and acid radical SO4 2 minus, aluminium cation and sulfate anion. And we can give one more example, say BaCl2, barium chloride, wherein the basic radical is Ba2 plus and acid radical is Cl minus. So such kind of inorganic salts are called as simple salts. That means simple salts are the inorganic salts consisting of one acid radical and one basic radical. That means only one type of acid radical and one basic radical. See, we have one Ba2 plus ion and two Cl minus ions. They are of the same kind. Such kind of inorganic salts are called as simple salts. And suppose if you consider an inorganic salt, and if that is composed of two simple salts, if an inorganic salt is composed of two simple salts, then such an inorganic salt is called double salt. Such an inorganic salt is called double salt. That means the double salts are the inorganic salts. They are composed of two simple salts. Two simple salts. So for example, I shall give one small example for a double salt. Let me consider one simple salt, CaCO3, that is calcium carbonate, when it is combined with one more carbonate, that is magnesium carbonate. So here we have combination of two simple salts, calcium carbonate and magnesium carbonate, and this is one simple example for double salt, and we call this combination as dolomite. And we can go with a few more examples. Say KCl is one simple salt, MgCl2 is another simple salt. When they get mixed and they will get hydrate to form hexahydrate, KCl, MgCl2 and 6H2O. This is another example for double salt, and this double salt is called cornellite. And here we said aluminium sulfate is one simple salt. Say Al2SO4 thrice. This is one simple salt. And when it is combined with one more simple salt, K2SO4, potassium sulfate, and the combination get hydrated, say 24H2O, this hydrated double salt, that is Al2SO4 thrice and K2SO4, this double salt is simply called potash alum, which is used in the purification of water. And we can give one more example for a double salt, a very well-known material, say FeSO4 and NH4 twice SO4, say around 6H2O, hexahydrate. It's a very well-known compound for us, ferrous ammonium sulfate, simply called FAS, ferrous ammonium sulfate, and it is commonly called Morse salt. These are some simple examples for double salts. And one thing we are supposed to remember with respect to the double salt, that is, double salts are stable only in solid state. That means when we are existing in the pure crystalline state, then only their existence is possible. But when these double salts are dissolved in water or in any other suitable solvent, they get splits into corresponding components. That means if you consider this KCl, MgCl to 6H2O, that is cornellite, so this will remain in the hydrated form and the two salts were bound together in their lattice. But once this cornellite is added to water or in any suitable solvent, the salts will get split to produce the corresponding ions. That means they are not retaining their properties in the solution state. They are getting splits up into the corresponding ion. And if you check out the characteristic properties, that means both physical and chemical properties of the any double salt material in the solid state as well as in the solution state, the properties will remains the same for those of the individual compounds. Okay, so that means we can say they are stable only in the solid state but split into respective ions in solution. That means they are not stable in the solution state. They are stable only in their solid state but not in solution state. And as I said, the properties will remain the same for the double salts in their solution state also. That means the characteristic properties of the corresponding constituents in the solid as well as in the solution state will remain the same. Such kind of salts are called double salts. And we said the double salts will split into the respective ions when they dissolved in water. That we shall see if you consider the cornellite itself, that is KCl, MgCl2, 6H2O. So when they add it to water, when this cornellite is added to water, it completely splits into K plus, Cl minus plus Mg2 plus 2Cl minus plus 6H2O. So like this, they undergo complete dissociation. This word you are supposed to remember and understand. The double salts will undergo complete dissociation when they are dissolved in water or in any suitable solvent. Okay, and there is no clear existence of the compounds in the solution state. KCl cannot exist as KCl itself. So it splits into corresponding ions, K plus and Cl minus. MgCl2 is not existing in the solution as a molecule. It is splitting into corresponding ions, that is Mg2 plus and Cl minus. So they will be completely dissociated once they added into a suitable solvent. That means, once again we can say, the double salts are stable only in the solid state, but the splits into respective ions in solution means they are not going to stable in the solution state. Next, the main terminology under coordination chemistry is a complex salt. So till now we said about simple salt and double salt, and now the most important one, that is complex salt. So in case of double salt, we said a double salt will be composed of two simple salts, that means consisting of two acid radicals and two basic radicals. But if you come to the case of complex salt, so name itself telling you it is complex in nature. That means there will be more than two simple salts will be there in a complex salt. But in actual sense, we cannot say like that. A complex salt is formed when two or more chemically distinct materials were combined with each other. We will be getting a certain kind of material in the form of a complex, and such electrically neutral compound what we used to get, that will be called as complex salt. We shall consider one simple illustration and try to explain the exact meaning of complex salt. Say if you are having a solution of nickel chloride, the solution of nickel chloride will be green in color. The solution of nickel chloride is greenish, and to the solution of nickel chloride, if you added the aqueous ammonia, when the aqueous ammonia is added to a green colored solution of nickel chloride, the green color will slowly get disappear, and it results in the production of purple colored solution. Purple colored solution. So if you observe why the color change is observing, that is the nickel chloride is greenish. Once you added aqueous ammonia, you will be getting a purple colored solution. And we know that nickel chloride is a simple salt which consisting of Ni2 plus and Cl minus ion. And the solution of nickel chloride will be consisting of Ni2 plus ions. But upon addition of aqueous ammonia to the solution of nickel chloride, if you check out the amount of Ni2 plus ions present in the solution, the concentration of Ni2 plus ions will slowly disappear as you add aqueous ammonia, and almost will get disappear. There will be no presence of Ni2 plus ions in the solution when you continue the addition of aqueous ammonia, till we get a dark purple colored solution. And if you evaporate this purple colored solution, you will get a purple colored crystals. And if you cross check the exact configuration of this purple colored crystals, the purple colored crystals will be having the material like this: NiNH3 6 times Cl2. So this is the formula of this purple colored crystals, what you get when you evaporate this purple colored solution, which is obtained by the addition of this aqueous ammonia to the green colored solution. So when you mix this nickel chloride and aqueous ammonia, these two are completely distinct materials, chemically different. But when the mixed with each other, there occurs a change in color, and we are getting once again the solid material upon evaporation, which is having the formula like this. And here, if you cross check this material, I mean to say, when you add this material into water, you are not going to get, or you are not able to identify presence of free Ni2 plus ion. That means when you add this material into water, it will give like this: Ni, NH3, 6 times with the 2 plus, and there will be 2 Cl minus ions. You can observe the species which is written enclosed within the square bracket is not allowing its components to come out into the form of free ions or free components, but the component which is present outside the square bracket is coming into the free state. That means here what we got, a complex, I mean to say, is salt. What we get is simply called as complex salt, and such complex salts will show completely different properties from the components from which it has been produced. The properties of this complex salt is completely different from the properties of Ni2 plus and properties of ammonia. Okay, so they are completely different, and you can observe. So we are having purple crystals of this material, and it remains the same. It remains the color of purple even though when you add it into water. That means this purple colored crystal is nothing but a complex salt which is produced, is retaining its property both in its crystalline form as well as in the solution state. Such a kind of complex salt which retain their identities even in dissolved in water or when they are present in complete crystalline state, such complex compounds are simply called as coordination compounds. Such complex salts are called as coordination compounds. The reason for calling this materials, this complex salts, as a coordination compounds is, here you can observe one Ni plus 2 plus, a metal ion is there. For that metal ion, there will be attachment of certain definite number of groups, and these groups will be attached to this metal ion through a special type of bond which will be indicated like this, and this is called coordinate bond. Since the groups are attached to a metal ion through the coordinate bond in developing a complex salt, such compounds are called coordination compounds. So we shall go with some basic terminologies that comes under coordination chemistry. So in order to better understand the core concepts of coordination chemistry, it is very much required to understand the basic terminologies that comes in coordination chemistry. And now we shall try to understand some of the basic terminologies that comes under coordination chemistry. The very first one is complex ion. If you consider a coordination compound, that is a complex salt. So let me take one, CuNH3 4 times SO4. So here it is a coordination compound or simply a complex salt, and here when you split or when you add this particular coordination compound or complex salt into water, obviously it gets splits into give CuNH3 4 times plus SO4 2 minus. Since we are having 2 minus over here, this will having 2 plus. So when a coordination compound or a complex salt in particularly, when it is added to water, it is split to give these two ions. And among these two, if you notice this one, it consisting of a metal ion or metal atom, anything it may be. So here it is, we are having a metal ion which is surrounded with certain definite number, that is 4 numbers of NH3 molecules, so as to get a charged species which is enclosed within a square bracket. Such a ion, so you can observe comparatively, compared with SO4 2-, it is far bigger one, and since it consisting of more than one component in it, such a species, such an electrically charged species which is obtained upon dissolving the coordination compound or a complex salt in water, which mainly consisting of a metal atom or ion surrounded by certain definite number of groups, and the group may be either a charged one or maybe a neutral molecule. Such an electrically charged species is simply called as complex ion. So how we can define the term complex ion then? It is an electrically charged species which mainly consisting of a metal atom or ion surrounded by certain definite number of species or groups which are charged or neutral. Such a ionic species is called complex ion. And if you consider this one, FeCN 6 times, and it is surrounded by 3 potassium ions, and when you dissolve this one in water, you will be getting 3 K plus ions and FeCN 6 times. So here we have 3 positive charges, so here you will be getting 3 negative charges. So here in this case, so we have iron ion which is in 3 plus oxidation state and is surrounded by 6 cyanide ions. So, and it is an anionic species, and this ionic species, what we got when this coordination or complex compound is dissolved in water, will be the complex ion. And you can observe the complex ion may be positively charged or may be negatively charged. If the complex ion is positively charged, we used to call that as complex cation. And if the complex ion is negatively charged, then we will call that as complex anion. We are not supposed to call a simple anion or simple cation. They are supposed to be called as complex cation and complex anion. So here in case of this coordination compound, we are having a complex cation, and here in this case we are having a complex anion. Here it is complex cation. So that is the logic how to identify the complex ion. And you can tag one more thing in order to better understand the concept of complex ion, that is coordination sphere. Coordination sphere. Here, if you consider any complex salt or coordination compound, so let me consider K4FeCN 6 times. So here I have a complex compound, and in this complex compound, what the thing we are having, that is K4, and we are having a square bracket, and it is enclosed with 1 iron ion and 6 cyanide groups or cyanide ions. The species which is mainly comprised of the metal atom or ion and certain definite number of groups, this or ions or groups which is enclosed in square bracket is simply called as coordination sphere. And whatever the component which is present outside the coordination sphere, that is called ionic sphere. That means the metal atom and the ions or molecules which are coordinated to the metal atom or ion through coordination bonds and is enclosed within the square bracket will be called as coordination sphere. and the coordination sphere may be a neutral one, may be a charged one. If it is neutral, not a big matter. If it is a charged one, then such charged coordination sphere is simply called complex ion. And in order to satisfy the charge present on the coordination sphere, we need some counterparting ions, and that counterparting ion will be present outside the coordination sphere, and that counterparting ions are called as ionic sphere. And here in this compound, potassium is ionic sphere. This FeCN 6 times is the coordination sphere, and here we have 4 positive ions. That means 4 positive charges will be there, so that on the complex will be having 4 negative charges. That means this coordination sphere is having complex anion, and to counterpart that charge present on the complex, we are having ionic sphere. And as I said, the coordination compound whole and solely, the coordination sphere may be negatively charged, positively charged, or even it may be neutral also. So let us consider 3 examples for each. That is, the coordination sphere having positive charge, coordination sphere having negative charge, and coordination sphere without any kind of charge, that is neutral. So let us consider this one, CO NH3 3 times Cl3. You can observe here I have not written any ionic sphere either on the left or on the right. So that means this complex material, that is this coordination sphere, doesn't have any charge on it. That means 0. So here the coordination sphere is neutral. And if you consider CuNH3 4 times with 2 plus. So here the coordination sphere is positive. That means it is a complex cation. And FeCN 6 times with 3 minus charge. So here the coordination sphere is having negative charge. That means the coordination sphere is a complex anion. So likewise, the coordination sphere is the one which is enclosed with, or which consisting of the metal atom or ion, and it is completely surrounded or joined by certain definite number of molecules or ions through the coordinate bonds, and is completely enclosed within the square bracket, and that species is called as coordination sphere. And the coordination sphere may be neutral, may be positive, may be negative. If it is negative, we call that as complex anion. If it is positive, we call that as complex cation. And if it is neutral, nothing to say, it is just a neutral coordination sphere. And that's about the term complex ion and coordination sphere. The next terminology under coordination chemistry is central metal atom or ion and the ligands. So it's a very important concept under coordination chemistry. In order to understand all the remaining stuff that comes under coordination chemistry, we are supposed to better learn these two terminologies, that is central metal ion and ligands. If you consider the complex compounds that may or may not contain an ionic sphere, if you focus on the coordination sphere only, in that coordination sphere, either ions in this case and molecules in this case, they will be present around a central metal atom or ion. The ion or atom to which one or more neutral molecules or ions are directly bonded with the coordinate bonds will be called as central metal ion or central metal atom. So I can say once again, the atom or ion to which, here the atom in the sense the metal will be always existing in the form of cation. So we can say the cation or to the metal atom to which one or more neutral molecules or they may be ions that are coordinated will be called as central metal atom or central metal ion. And the ions are neutral molecules that are bonded to the central metal ion are called as ligands. So here in this case, in this particular thing, Ag, which will be existing in the form of Ag plus, this is central metal ion. And here in this case, Ni will be present in the oxidation state of 0. So here it is central metal atom. So on upcoming topics, we shall see why here the oxidation state of Ni is 0 and why it is plus. So for this instant, let us see in this particular complex compound, the central metal ion is Ag plus, and here the central metal atom is Ni. And here in this case, the ligand is cyanide, which will be in the form of minus state. So cyanide anion, which is the ligand material over here. And here CO, that is carbon monoxide, which is called as carbonyl, and is the ligand over here. So first we need to understand the exact meaning of the term ligand. So ligands or the species, they will donate electron pairs to this central metal atom or central metal ion, and thereby forms a coordinate bond with that central metal ion or central metal atom. So we can simply define the term ligand in this way. Ligands or the ions are neutral molecules which will donate one or more electron pairs to the central metal ion. I mean to say, the electron pairs which are present in the valence shells of these groups, they will be donating, and by donating the lone pairs or electron pairs to the central metal atom or ion, they develops a coordinate bond with that central metal ion. So those are the components, that is the exact meaning of ligand. If you want to define the term ligand, we can simply say ligands or the ions are neutral molecules which develops coordinate bond with the central metal ion by donating one or more electron pairs to it. That is the simplest definition we can give for a ligand. Fine. And the ligand, here I said it is the ligand is an anionic material, and here the ligand is a neutral molecule, and even the ligand may be positively charged also. That means a ligand may be neutral or even it may be charged one. So if you consider one more example, FeCN 6 times with 4 minus charge, and here in this case the central metal ion is Fe2 plus, is the central metal ion, and the ligands is Cn. This is the ligand material in this particular complex. So in this way, we can easily notice the central metal ion and the ligands that are present in a particular complex salt. So in the next video, we shall try to learn about the classification of the ligands.